Hello everyone. Today I will explain the concept of the caching, right? Currently now there are trend of the internet, right? So obviously you are using the YouTube, Instagram, and you see you are like swiping the reel and it will be very fast. It will come without any loading, right? As well as if you watch any YouTube video as well, you can see the speed of that YouTube loading of that video is fast, right? So how in the backend system it will implement it. So basically the solution is the caching, right? So in the Instagram server or in the YouTube server, they internally at the end they are doing the some level of caching, right? So that concept I will explain little bit, right? So first of all, what is the caching is, right? So caching is a technique, right? So we can store uh, the copy of the original data somewhere so it can be retrieved quickly, right? So that is the caching. And we can also store the computational data, right? So we no needs to calculate it again and again. So that is called the caching, right? Now, so first of all, what we have learned is what is caching. So that is copy of original data, original and computational data that can be retrieved quickly. That is the important. It can be retrieved quickly. Right now, uh, if we have to retrieve quickly, so we have to store into some storage, right? So there are many kind of storage, right? For example, if I am making any request from my laptop, then from laptop to the internet to the backend service, there are lots of storage are present. So let me explain like how many storage is present, right? So first of all, the storage is present inside the user laptop itself, right? So for example, I am using my laptop to browse some website, right? For example, I have opened the Facebook in my laptop, right? So in the laptop itself, laptop have lots of memory. So uh, the memory which is very near to the CPU is CPU register. CPU register. Then we have L1, L2, L3 cache, right? Then we have RAM. We uh, we have SSD, right? We have hard disk. So these are all are the like hardware level cache, hardware cache, right? So the CPU register is very closest to the CPU, while the hard disk is it is very far from the CPU, right? So so the memory basically there are lots of memory. So the memory some memory are like very less, but it is very efficient, I mean very faster, and some memory are used, like for example HSD, but it is very slow, right? For example, CPU register work in the nanoseconds, right? While the RAM work in hundreds of nanosecond, while the hard disk and SSD running in the millisecond, right? So yeah, that is the hardware level cache that is present in the laptop. The second cache that is also present inside the laptop itself, that is called browser caching, right? So we are using for example Chrome. So Chrome itself have lots of memory. For example, for example, DNS. For example, we've read the google.com, so it will retrieve the IP of that google.com domain from the caching itself. So that is called DNS cache, right? DNS. The second storage that is present at the browser level is local storage, right? Which is uh, local storage is basically domain wise. For example, google.com, if we've read the google.com, so google.com have its local storage. If I'm using the Facebook, then Facebook each have own local storage. So the second is local storage. Every tab have one another storage that is called session storage. Session storage. So basically, this cache are basically used to like improve the performance. For example, I'm like viewing the website for the first time. Now I'm viewing the same website for the second time. So you also face like it will be loading very fast. So that is because of the local session kind of storage, right? So this is browser cache. Third cache is CDN, right? So now my request goes to the CDN, which is actually server. For example, this is my client laptop, right? Now the server is goes to CDN, CDN. Then it goes to app server, which is called backend server, app server, and finally it goes to the database, right? So in middle in middle between app and DB server, sometimes we have the caching server. Right. So in there is one layer called CDN that is exist in between app server and your local computer. So CDN full form of CDN is content delivery network, correct? So what CDN will do is, so CDN actually place the multiple server in multiple geographical area. For example, one server in the India, second server in the US, right? So whenever I am using the youtube.com from the India, so my request is only goes to the India server, not the US server. So in that way, CDN is a caching, so it will reduce the latency of my request. If CDN not exist, and all the request goes to the US servers, so the time between the request is very high. So CDN is very important, and there are many CDN provider, CDN service provider are exist. For example, AWS CloudFront, Cloudflare, those are the CDN provider, right? So now finally, uh, the another storage is local or global storage. Local or global storage, that we will talk it later, right? After completion of this topic. And the last storage is DB, database, where our actual data is present. So in that way, the storage is always hierarchical, right? So some of the storage is very huge but very slow, and some of the storage is very small in the size, but it is very faster, right? It will compute the data in the nanoseconds, right? So in that way, if we hit the request from the browser, so so in this like there are multiple layer possible where we can cache the data. So in the real world there are multiple number of caching layer is present, right? Now let's see what is the difference between local and global storage here. So now let's see what is the difference between local and global storage. So for example, this is my backend architecture, right? Backend, where my all the database app server are present. So there are multiple app server is present. App 1, app 2, app 3, right? So in the backend there are multiple services server are possible. So that is also called the microservice architecture, right? So there are multiple app server present. So if we store data to the every app server, for example here, if we store any data into the every app server, that is called local storage. And if we store any data into the app server, so it will not call the like stateless architecture, because we are storing states into the app server. So it will be a stateful architecture. So that is the local storage, where we can store the data into the app server itself, right? So that is the local service, local storage. If we like, so there are multiple global caches also possible. For example, the Redis, right? So we can store the data in the Redis itself, right? So that is called the global server. So uh, first they checks app server check into the Redis if the data is present. If present, otherwise it will goes to the DB. So finally DB is present here. This is called DB. Alright. So now you will understand what is the difference between local storage and global storage. So if we store any data to the app server itself, then that is called local storage. And if we store data outside of the app server, that is called global storage. For example, the Redis, and there are Memcache also provide the same service as well. Memcache, right? So that is the difference between local storage and global storage. Now, so all are the actually the caching, right? If we store any duplicate data into the memory, that is called the caching, right? Now, what is the actual challenges that we face with the caching? So there are mostly two challenges we can face if we use the caching. The first is source of the truth. First is source of truth. What do you mean source of truth? It means we actually store the actual data into the DB itself, right? But we are storing the copy of that data to the caching, right? So there will be a chance where we can actually get the stale data, right? For example, if I am a user, right? If I am a user and my request goes to the first directly to the DB, right? And there is one caching layer, right? So I have stored the user data. For example, I am say my name is Nigam, right? I have stored that Nigam name into the database. Now, if I am hitting the second request, so it will be coming from the cache itself, right? For example, uh, Nigam is coming from the here. Now, if I am editing my name, I am editing my name from Nigam to Nigam Patel. Nigam Patel. So in between, if user again request for the my name data to, then it will again go to the cache, and so in the cache itself there is all the data, right? That is called the Nigam, but the actual name present in the database that is called Nigam Patel, right? So there is a stale data that user get. So that is the actually the problem, right? So that is the called source of truth problem. So there are multiple cache invalidation policy are present. So we have to cache invalidation. What do you mean by cache invalidation? For example, we have to invalidate the cache. So in the previous example, we have to invalidate the older name, right? That is called the nigam. So that user can get the latest data. So that is, there are multiple cache invalidation policies present, right? That we will learn it later. For example, the TTL, uh, cache around, cache through, cache behind. So there are multiple cache invalidation policy present. We will learn it later. So now the uh, thing is second challenge is that we can face with the caching is the storage, right? So basically, in the caching server, uh, in the caching server, the storage is very less, right? What do you mean by very less? For example, the Redis. So all the storage are present inside the RAM itself, right? So there are limited number of storage present for the RAM. So that is the problem, right? For example, let me give one example. So for example, I have user data in the database. For example, one take about the YouTube video, right? So in the database itself, there are lots of data present inside the database. There are TBs of data inside the present in the database. So we cannot keep the every data to the cache itself, right? So otherwise it will it will be the same, right? I am storing the every data to the cache. So it will again the we get the data slower. So what we actually put into the cache, so that is very frequently used, right? So if we add new data into the cache, so we have to remove the older data, right? Otherwise the cache is going to bigger and bigger and bigger. It will at the end the db size and the cache size will be the equal. So that will be a very not good practice. So we have to somehow we have to remove the older data. That is called cache eviction policy, right? Cache eviction policy. For example, LRU, that is called least recently used, FIFO, first in, first out. There are also others policies present. So let's understand what this policy quickly, right? So what the TTL policy means. So for example, so inside the cache itself, we have key and value. So inside the actually the cache storage, we have key value structure is present, right? So for the every key, there is a TTL, time to live, right? For example, if I'm adding user data and if I'm set the TTLs to 5 minutes, then that data will expire in the 5 minute. So if I'm get the same data at the 6 minutes, so it will be no longer exist, right? So that is called the TTL policy, right? The second policy is cache around, right? So in the cache around, what will happen? Let me draw one diagram here. What will happen in the cache around itself? So I am a user, right? Now I am requesting, I am first of all adding the database, adding some value user data to the database. Then it will first go to the DB, right? And there is one cache itself. So I have added the user data. Now if I am actually post the user data. I mean adding the user data. Now if I am retrieving the user data, then it will first check into the database itself if it is present. If not, then it will request from the database itself and store into the database. So where if user comes to the second time, then user can directly get the data from the database. Now if again they are requesting the user data, so user data is always is present into the cache. So now user no needs to go to the DB itself, right? So that is called the cache hit, right? We actually getting the data from the cache, right? So in that way happen. Now what will happen in the cache around? So in the cache around, so this is the actually flow. Now in the cache around, uh, uh, so this data will be a stale, right? For example, now if I have updated the user, right? User edit. So now again request to the again requesting from the cache. Now inside the cache we have older user, right? So user can get the stale data, right? So how we can like make sure that user get the latest data? So in the cache around policy, what we have one cron job that periodically run, and it will copy the data from DB to cache, right? For example, uh, every 5 minutes a cron job will what will it will do? What it will copy every user from database to the cache, right? So in five minute of interval, user can get the old data, right? But after 6 minutes, a cron job have updated the DB data to the caching, right? So from the 6 minute, user will get the latest data, but in the 5 minute there is chances of the like stale data. So that is called the eventual consistency, right? So it will eventual consistency, because like some time user can get the stale data. So from the cache around, we can get the eventual we can achieve the eventual consistency, not the what we can say, immediate consistency, right? Now so let me actually let me refigure what we have learned. So in the TTL, there is one expiration that we have to set for the every key. So after that time, key will be automatically removed from the database. So in that TTL as well, there is chance. So that is from the TTL we can achieve the eventual consistency, not the eventual consistency. Not achieve the we cannot achieve the immediate consistency in the TTL itself, because if I have set the 10 minute of TTL, and if user request comes, so in 10 minute of duration actually user gets the stale data, right? So that is again the eventual consistency. So let me explain what is the eventual consistency and immediate consistency. So inside the immediate consistency, like user get always the latest data, while in the eventual consistency, user will get the latest data, but for the some time for the some cases for some time there might be a chances where user can get the stale data. So that is called eventual consistency, and this is the immediate consistency. So from the TTL and cache around, we can achieve the eventual consistency. Now this third thing is catch through. So whenever we are writing the user data, so we are writing in the earlier we are writing only data to the DB. Now in the cache through, we are writing the data to database as well as the cache itself, right? So so now user can get the latest data every time, because if I am writing anything or I am editing, I am doing the same operation into the cache itself, right? So user will get the latest data always. right? But what is the problem with catch through policy? So since we are writing the same data to the caching uh, uh, as well as to the DB, so the latency will be must be the higher, because we are writing at the two places, and there is a chances of failure. For example, if I have written the data into the DB, but when I am writing the data to the caching, then it will fail, right, somehow. So there is chances of failure, but we can achieve the same thing using the two-phase commit. For example, if you transaction and commit, you see that kind of concept. So we have to like a rollback kind of concept we have to implement in the cache through itself, right? So like in real world where we can use the cache through, so where the actually the immediate consistency is required. For example, the banking software, right? Banking software where the like consistency is important, right? Where we can use the cache through. Now the last is cache behind, right? So in the cache behind, what will happen? We write the data to the cache caching at the cache storage only, right? We not write the data to the DB, right? For example, here if I am writing the user data, then it will store into the cache server itself, cache server only, not to the DB. So at the later on cache, we can dump the cache data to the DB. That is called the cache behind, right? At the later we can like dump the caching data to the databases, right? So if since we are writing the data to the cache server and we are returning the data from the uh, like cache server in the cache behind, so it will be a very faster. So in the real world scenario where the cache behind is used, so in the gaming software, for example, we are writing everything in the caching, we are retrieving from the caching, so it will be very faster. But what is the problem in this? So for example, if I have written the data into the cache server, and somehow before it will dump the data to the database, my cache server will be crashed. So in that case there is a chances of cache failure. So in that case we have a data loss, right? So where we can use the cache behind a policy where the data is not much important. For example, Facebook like, right? For example, I am liking one post, right? So there are multiple user, like hundreds or millions of user liking the post at the same time, right? So that count is not important, right? So if one or two count is mismatched, then it will be okay, where the consistency is not required but the speed is required, the experience is required. So in that case we can use the cache behind policy, right? And so these all are the cache invalidation policy. Let me again quickly go through it. So in the TTL, from the TTL and cache around, we can achieve the eventual consistency. From the cache through and cache behind, we can achieve the immediate consistency, right? Immediate immediate consistency, right? In the We can use the TTL and cache around, where if the stale data is okay, then we can use the TTL and cache around. For example, the LinkedIn post, right? So if I'm updating the LinkedIn post, then if some user get the old post, then it will be fine. So in that case we can use the TTL and cache around. And the cache through, where we can use the cache through where the consistency is required, for example the banking system, and that is from that we can actually achieve the immediate consistency. And where you can use the cache behind, where the data is much not more important, right? For example the gaming, right? So in that case we can use the cache behind. So that is the cache invalidation policy. From that we can invalidate the cache, so user can get the latest data always. Now the second policy that we have discussed is cache eviction policy. So we have to remove some data from the storage. So that is the easier one, LRU. For example, if new data come, then if the data that is present in the cache which was actually used less time, right? For example, only used once, so we can use the we can remove that. So that is the list recently used. So the item which are used less, that we can remove it first. The second is a FIFO, first in first out. So whichever item we have stored first in the cache, that we have to remove first as well. So that is the FIFO policy. So this is the all about the caching. So in the cache we can, so caching is the basically important topic in the high level design as well, where if you learn only this caching concept, then you almost cover 50% of high level design, right? Yeah, that's it from today from me. If you if you like if you if you think that my video is important and knowledgeable, then please hit the like button and subscribe my channel, right? So it will motivates me to uh, create another video for you, and like uh, like give the knowledge to you, right? Yeah, thank you for watching. Bye bye.